Here we go, here we go. We're going to start graphing some sine and cosine waves, and the general formula is A, and then whatever trig value we're going to use sine or cosine for this. There are tangent, cosecant, secant, and cotangent waves as well, but we're just going to work with sine and cosine. And then we have a B, which is a value that we're going to be using as well. Then it's x minus c, and then we have plus d. Now, each A, B, C, and D does something different. So today we are just going to talk about A and D, and then the next video will wrap up with B and C and tie it all together. So A stands for amplitude, which is how high or low these waves are going to go. And D is the vertical shift, how high we move or how low we move the entire graph. So one thing you need to know is a period. A period is when the graph will start to repeat itself. And for both sine and cosine, that will always be 2 pi, which, if you think about it, in terms of the unit circle, a circle is 2 pi, or 360 degrees if we were in degrees. So, sine and cosine waves look very, very similar to one another. The only difference is where they start. Now, on the x-axis and the y-axis, they're going to intersect right here at the origin, and that is where a sine wave starts, and we'll discuss why in just a second. And for cosine waves, they start up at 1 on the y-axis when x is equal to 0. Now, here's why. Let's think about this in terms of the unit circle. Now, in a unit circle, we have a graph, and we're going to graph an angle that starts right here at the positive x-axis. And his starting coordinate is 1, 0. And from 1, 0, we start to go this way. And then eventually you'll end up at your next coordinate, which is 0, 1. And then you're going to continue going this way. So this is when you're at pi over 2. And then once you get to 1 pi, look at your coordinate now. It's negative 1, 0. And then finally, you're going to get all the way down to here, which is 0, negative 1. And then, as you can see, you're going to end up right back here at 2 pi, also known as 360 degrees, which is right back at your starting point, and then it starts to repeat itself all over again. That is why you have 2 pi for a period when it starts to repeat itself. Now, the other thing is, notice what our x and y values represent again. So, to look at the first one, sine, the value for sine is the y value. So, at 0 radians, we have a y value of 0. So, at 0 radians, the x-axis represents theta. And then the y value on the graph represents your sine of x, which matches with your y value from the unit circle. So, at 0, y is 0. Once you get to pi over 2, your y value or sine value is 1. That's why you're at pi over 2, 1. Once you get back to pi, or 180 degrees, your y value is 0 again, so you get back to 0. And then once you get to 3 pi over 2, you are back down with a y value of negative 1. So look, our theta is 3 pi over 2 on the unit circle, but now we're down at negative 1. And then finally, we wrap up by getting back to our starting point, which is why we start right back here again, and then it's going to start to repeat itself. So that's why that happens. Exact same thing with cosine, only difference is we are now looking at the x value. So y is actually equal to the cosine of x, which corresponds to the x value on the unit circle. So if we go back and look at 0 radians, our x value is 1. That's why it starts up here, because cosine of x is 1. And then we get to pi over 2. What is our x value? It's 0, so that's why they're different. And you can see we're just going to go around the same and find our x values instead of our y values on the unit circle and just plot them on a graph. So basically what you're doing is you're just taking an angle of rotation and you're stretching it along one axis instead. That's the only difference. Okay, so let's practice with it now. 3 sine x. We're just going to work with what the a and the d value does today. So the a value, again, is your amplitude. So your amplitude is 3. So if we go back and just take a quick peek at what this is, notice how everything was on the x-axis. So the only difference is now the amplitude is 3. So sine is still going to start right there at the origin. But now this is a little tip for you. An amplitude is how far you are away from your starting line. So our x-axis is here. Our top is going to be 3 units above, and 3 units below will be your bottom of this graph. This is actually called your crest and your trough. And this center line is actually known as your node line. So, but however we're going to do this, we're going to start here. Now, since sine is positive here, the only thing that means is we're going to go up, but now we're going to go all the way up to the top. And you always bounce back and hit your node before you go all the way down to the bottom, before you bounce back and hit your node. So this is what the first positive period looks like. To go negative, you just continue the pattern. So this one, instead of, we don't bounce back up now, we go down in this direction until we hit the bottom. You always go back to the node before you go back to the top. You always hit the node before you go to the bottom. So then this is exactly what that graph looks like. Okay? And to align your tick marks here, remember a period is every 2 pi. So this is your 2 pi. To find all these interval marks, you just have to take your period and divide it by 4, and that'll give you pi over 2. So this is your pi over 2. This is pi. This is 3 pi over 2. And that's 4 pi over 2, which is 2 pi. Okay, and it works the same way by going backwards. And that's it. That's how you graph a sine wave. This next example shows you what happens when you just have a vertical shift. Notice that the amplitude is 1. There's never an amplitude of 0. There's going to be an amplitude of 1. If there was an amplitude of 0, that takes away the whole cosine wave altogether. So we have an amplitude of 1. But now we have a vertical shift of up 2 because it says plus 2. So what that means is we are going to shift the entire graph up 2 units. So what I recommend that you do is you draw a new node line. So instead of shifting every point up, just start with a new node. So that's now where that's your reference. That's your reference line. That's where you're going to be above and below. So now your amplitude is 1. Your high part, also known as your crest, again, is 1 unit above the node, and your trough is 1 unit below the node. And that's it. Now you're ready to graph. So this is a cosine. So cosine, as you remember, starts at the top. And now all you have to do is follow the pattern. Start at the top, hit the node, go to the bottom. Go back and hit your node, go to the top. Going the other way around. You're at the top, going backwards. You hit the node, hit the bottom. Go to your node, hit the top. Remember, you never go straight from the bottom to the top. You always have to have a dot on the node on your way. And that's it. There's your cosine wave, shifted up 2 units. The last example here covers both. But then there's one other little trick to it. There is a negative. That's not a big deal at all. So we have an amplitude of 2. It's not negative 2. The amplitude is just the number in front, positive or negative. The amplitude's always positive, okay? And then we have the vertical shift. Our vertical shift is up 1. And then the negative just means it's reflected, or we can say upside down if you want. But it's reflected. So what's going to happen is this. We're still going to start with our node line. I like starting with the node line. It helps. So we are going to shift up 1. So here is your node. That's the first thing you should do is plot your vertical shift. And then our amplitude is 2. So the amplitude means 2 above the node is your top and 2 below the node. So this is a sine wave. So we know sine starts right here. The only difference is a positive sign usually goes up. The negative sign means we're going to go down first. So we're going to go down 1 tick mark to the right. And now we're going to bounce back to the node, go up to the top, go back to the node, and you're done. In the other direction, we're just going to continue this pattern. So this is going to be going up, and then back to the node, down to the bottom, back to the node, and then all you have to do is swoop all the way till you get to the end. And that's it. That is graphing sine and cosine waves. So quick little recap. Positive signs versus negative signs. Sine will always, if we think about this in terms of 3 spots. We've got our origin, our positive 1 and negative 1. Positive signs will always start here and go up. Okay, that's a positive sign. Negative signs will always still start at the origin, but go down. Positive cosines always start at the top first and go down. And negative cosines will always start at the bottom and go up. Okay? So cosines will start at the top or the bottom. Sine will always start at the center or your node, and it'll just either go up or down depending on if it's positive or negative. Okay? So that's it. That's the basics of sine and cosine waves. The next video will get into what happens when we change the period or if we shift it right and left. All right? This is Longo and I'm out. See you. Bye.